beginning we have understood that we follows only 3 steps. One is concentration of the ore, next one is conversion of concentrated ore into oxide form, and third one is a refining. If the particles is not attracted towards a magnet, it will be separated out in a separate container and it is known as non-magnetic ore particle. So when the rotating panel is continuously rotating on the container, it will form a froth. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in this session, we are going to discuss with the new unit called as General Principles and Process of Isolations of Element. So before going to understand this unit, so first we will understand what is a minimum weightage for this chapter. So from this chapter, we can easily get one 1-mark question and one 3-mark question. And the question number 6 from the 1 mark and the question number 19 from the 3 marks will come from this unit. And the total weightage for this unit is 4. So totally we can expect 4 marks from this unit, and it is one of the easiest unit in your second PUC chemistry. Now let's see what we are going to discuss in this session. In this session, we are going to discuss with the introductory part of this unit. Under that, we are going to understand what is metallurgy, what is mineral, what is ore, what is gangue, that and all we are going to understand in the introductory part. And also in the occurrence of the metal, we are going to understand about the 4 important occurrence of the metal along with the ore. Next, we'll go for the steps which we followed in the metallurgy. The first one, that is a concentration of the ore. Under that, we are going to learn with the 3 different processes. First one is a hydrolytic washing and magnetic separation and a fruitation process. So first we will see what is a metallurgy, what is a mineral, what is a ore, what is a gangue. Let us understand now. So metallurgy, it is very simple. It is nothing but a branch of the science. It deals with the extraction of the metal from its ore. So metallurgy is a branch of chemistry which deals with the extraction of the metal from its ore and refining of the metal, which is known as metallurgy. So it is a process of extraction of the metal from the ores and refining it. Refining means purification. So after obtaining the metal from its ore, we go for the refining process, that is a purification process to obtain the pure metal. So such branch of chemistry, it is known as metallurgy. So in the metallurgy, before going to understand this unit, we need to know some of the important terminologies. The first one is a mineral. Now let us understand what is a mineral first. Okay, mineral are the compounds of the various metal which is mixed with the impurities and found in the nature. Minerals are the metals, usually they found with the many impurities and it is always found in the nature. They are known as minerals. Next important terminology is ore. Ore is a naturally occurring mineral from which metal can be profitably extracted or conveniently extracted. Remember, ore is a mineral from which metal can be extracted profitably. And remember, all the ores are minerals, but all minerals are not ore. So this is the 2 differences between ore as well as with a mineral. Remember, mineral is a metal which is always bonded with the impurities and it is always found in the nature. Whereas our ore, it is nothing but a mineral where you can extract the metal profitably. And remember, almost all the ores are mineral, but the minerals are not ores. Hope you all understand my words. Next is gangue. Remember, the gangue are the matrix, which is nothing but the impurities which is found in the ore. So the impurities such as the sand, rocky material and the limestone and the mica which are present in the ore are known as gangue or the matrix. So the matrix or the gangue which are nothing but the impurities. For example, if you got the iron ore, it always bonded with the rock or with the stones or with the sand also. That unwanted substances which is bonded with the minerals or which is bonded with the metal, which is said to be gangue, which is nothing but the impurities which is always present in our ore. And also, after understanding this, all the three important terminology, that is mineral, ore, as well as with the gangue, we must know that what are the steps which we followed to get the pure metal. So, in the metallurgy, we follow the three common steps. The first one is the concentration of the ore, okay, and next one is conversion of concentrated ore into oxide, and third one is a refining of metal. So these three are the important steps which we followed in the metallurgy. These are the three important steps which we followed in the metallurgy to obtain the pure metal. Which are the steps? Concentration of the ore, then converting the concentrated ore into oxide form, then last one is a refining. So in the concentration of the ore itself, we follow the 4 different methods. Let's understand that later. Okay. Hope you all understood with this branch of chemistry, and it is one of the interesting branch in the chemistry and one of the easiest branch in the chemistry to study. Hope you all understood with the what is the metallurgy along with the 3 important terminology along with the step. Next, we'll see some of the important metal, how do they occur with the ore. Let us understand. That is, here I have listed out 4 important metal. First one is the aluminium. The ores for the aluminiums are the bauxite ore and kaolinite. Kaolinite and the bauxite ores are the 2 important ores for the aluminium, and the composition are AlOX and OH 3 minus 2x, where the X is greater than 0 or lesser than 1, and for the kaolinite it is a form of clay, and the composition are Al2OH4 and Si2O5. Then for the iron, we have 4 different ores, that is hematite, magnetite, siderite and pyrites. For the hematite, the composition is Fe2O3, and for the magnetite, that is Fe3O4, for the siderite, that is FeCO3, and for the iron pyrite is FeS2. Then coming into the copper ore, again for the copper, we have 4 important ores: copper pyrites, cuprite and malachite and copper glans. For the copper pyrite, the formula is or the composition is CuFeS2, and for the malachite, that is CuCO3 and CuOH twice, and for the cuprite Cu2O, and for the copper glans it is Cu2S. Similarly, for the zinc, we have 3 O's, that is zinc blende, calamine and zinc site. For the zinc blende, that is ZnS. For the calamite, it is zinc carbonate, and that is ZnCO3, and zinc site is ZnO. All these 4 important metals you must know along with their ores. And it is very important for your board as well as for your competitive exams. Especially, this 4 important ore along with the ores, It is very important. Now you have understood that how the metals, which is always found with the ore, with the different combinations. In this chapter, you are going to understand all the extractions of this important metals. Okay. Next, we'll see how many steps we followed. In the beginning, we have understood that we follows only 3 steps. One is concentration of the ore, next one is conversion of concentrated ore into oxide form, and third one is a refining. In between these 3 steps, we follow the number of steps. Let's see what are those. So if I get the ore first of all, first I'll go for the grinding and crushing. So first I'll do the grinding and crushing, then I'll do for the concentration of ore, where you are removing the impurities. So here again for the concentration, we have 4 different methods: gravity separation method, magnetic separation, froth flotation and leaching. So these are the 4 important steps which we follow for the concentration of the ore. So either any one can be used, and it depends upon the type of ore we are extracting, okay, or the type of metal which we are extracting from the ore. Next is roasting and calcination. So here in the roasting and calcination, we are converting the concentrated ore into oxide form. And next one is reduction. In the reduction, again we follow the different step or the different method: reduction by carbon, reduction by electrolysis, reduction by carbon monoxide, reduction by aluminium and reduction by heat alone. These are the 4 or the 5 different technique which we follow for the reduction of the oxide ore. Then is refining. In the refining also we follow the 4 different methods. Either anyone can be used. Remember, it depends upon the metal or depends upon the ore from which metal is extracted. Okay. It is distillation, liquefaction, oxidation and electro-refining. And finally, we obtained a pure metal. So these are the steps or the general flow chart which we follow in the metallurgy to obtain the pure metal from its ore. So first what we used to do, first we'll take the ore, then we'll do the crushing and grinding, then we'll follow the concentration. For the concentration, we have 4 different steps, that is the gravity separation, magnetic separation, leaching and the froth flotation. Any one can be used. Any one of the methods can be used. After concentrating, we are converting that ore into oxide form by roasting and calcination. After converting that oxide forms of the ore, we are going for the reduction. Again in the reduction, we have different techniques. Any one of the techniques can be used. After that, we go for the refining. In refining, we go for the electrolytic refining or with the distillation, liquefaction along with the oxidation. And finally, you will get the pure metal. This is how the general outlook will be followed in the metallurgy to obtain the pure metal from its ore. Hope you all understood with this flow chart. Next, we'll see the first step in the extraction of the metal, that is concentration of the ore. Okay. The process of removal of the impurities from the ore is known as concentration. It is very simple. The process of removing the impurities. We all know that our metal, it is always bounded in the form of ores, and this ore, it is not a pure form of the metal, it is always containing a gangue. Gangue means it is nothing but the impurities only. So first of all, we need to remove all these impurities which is present in our ore. That process is known as concentration. Okay, and here in this process, this is also known as ore dressing or enrichment of ore. Why it is known as enrichment of ore? Because once you remove the impurities, your metal concentration or the ore concentration will be enriched or it will be increased. Hence, it is known as enrichment of ore. Next, This process, it is also based on the difference in the physical and the chemical properties between the ore and gangue particle. So this principle or this step, which it is always depends upon the physical and the chemical differences between the gangue along with the ore particle. Now let us understand how many different steps will be there and how we will do the concentration of ore by using a different technique. Let us understand now. The first one is hydrolytic washing, which is also known as gravity separation method. So here in this step or in this method, it is always depends upon the difference in the gravities of the ore with the gangue particle. So this technique, which mainly depends upon a difference in the density between the ore along with the gangue particle, or we can say that this technique is mainly based upon the principle called as difference in the gravity between the ore along with the gangue particle. How they will do this method? First of all, they will consider the conical reservoir. They will consider the conical reservoir. In that, at the top, they'll put the powder ore, that is the crushed and grained powder ore will be taken. At the bottom, they'll provide the water in an upward direction. They are pulling the water in the upward direction. Here the water will be moves in upward direction. At the same time, the powdered ore will be filled in a conical reservoir. What will happen in this case? We learned that this method is mainly based upon the gravity, difference in the gravity between the ore and the gangue particle. So that if the water is moving in the upward direction, what will happen? This sand particle will be dissolved in water and heavier particles, it collects at the bottom and it will be comes out in the form of concentrated ore. Whereas a lighter particle, it will dissolve in the ore and it will be comes out in the form of gangue. This is how, they'll do the separations of the impurity from its ore and they'll enriches the ore concentration, and hence it is known as hydrolytic washing. Remember why the name has given as a hydrolytic washing here? Because they are using the water to remove the impurities. Hence it is known as hydrolytic washing. And one thing you need to remember here, it is based upon the gravity differences. We all know that our ore itself, which consists of the metal, we all know that metals are heavy. Is it right? That is why it will be collected at the bottom. Whereas a lighter particle, which in the form of sand or with any other impurities, which will be comes out due to the floating on the surface of the water. This is how, they easily concentrated the ore by using water. Hence this process, which is known as hydrolytic separation. Hope you all understood with this method. Next we'll go for the second one, that is magnetic separation. Now let us understand what is a magnetic separation, how they will do the concentration of the ore by using magnet. Let us understand now. This method is based on the differences in the magnetic properties of the ore and the gangue particle. Very simple. It is nothing but a technique where we use a difference in the magnetic properties of the ore along with the gangue particle. We all know that our ore itself will be consist of metal and also it is bounded with some of the impurities. Whether that impurity or the metal attracted towards a magnet, the differences itself will be used here to separate the gangue along with the ore. Okay. So here we use some of the ores such as pyroxylite, tinstone and chromite. So these are some of the important ore which we used here to separate the ores along with the gangue particle. So here what we will do here, the powdered ore will be dropped on the magnetic roller or the belt, which is dropped over the belt running over the two rollers, one of which is a magnetic in nature. Here they have considered the two magnets and it is a belt which will be tightened between the two rollers. At the top, what they'll do, they'll add the powder ore or the crushed and grained ore will be added at the tops of the roller. So when the powder ore is running on the magnet, what will happen? We know that our ore itself, which consists of metal along with the impurities. Okay, which one will be get attracted towards the magnet? You know, it will be collected near the magnet. Which one is not attracted towards the magnet? It will be separated out and it is known as non-magnetic ore particle. It is known as non-magnetic ore particle. If the particles are attracted towards a magnet, they are known as magnetic ore particle. It is very simple here. They have taken the roller, okay, belt roller they have taken along with the magnets they have taken, okay. These are the magnetic roller and also they have considered the belt. At the top, they are pouring the finally crushed ore. When these ores are passing near this magnet, if any one of the metal or any one of the impurities, if it is attracted towards the magnet, it will be collect near the magnet only, okay, and it will form a magnetic ore particle. If the particles is not attracted towards a magnet, it will be separated out in a separate container and it is known as non-magnetic ore particle. This is how you know they separate the impurities as well as with the ore only based on the magnetic property differences. Hence, it is known as magnetic separation. So here the magnetic particles get attracted towards a magnetic roller and get collected near it, and non-magnetic particles drop away from the roller and it forms a separate heap. This is how, based upon the differences in their magnetic property, we can easily separate the ore from the impurities. So one of the important technique it is. Okay, hope you all understood with this technique. We'll go for the next one, that is a fourth fruitation process. For the examination point of view, it is very, very important. It is very, very important that can be asked for the 3 marks. Okay, now let us understand what is the basic principle behind this technique and how do they do the concentration of the ore. Let us understand now. Okay, this process will be used for concentration of the sulfide ore. The main principle is the mineral particles will be become wet by the oil, while the gangue particles will be wetted by the water. So this was a main principle. It is followed in the froth fruitation, whereas our minerals will be wetted by the oil, whereas the gangue particles will be wetted by the water. How they will do? Let us understand with the diagram along with the flow chart. And remember, this technique will be specially used for the concentration of the sulfide ore. Then, which are the steps they will follow? In the first step, they will take the powdered ore along with the water, along with the collector and also with the froth stabilizer. So, they will take the ore, they will add the water, they will add the collector and also they will add the froth stabilizer. Then, a rotating paddle agitates the mixture and draws the air in it. And fourth is formed with the mineral particle and the fourth is light and it is skimmed off. The fourth is drained and then ore particles are recovered. So this is how you know they will extract the mineral ore in the form of froth. Okay. Now let us understand with this diagram. Here they will consider the large container and they have introduced the rotating paddle. Okay, rotating paddle they have introduced, and here in this mixture they have considered the ore along with the water, along with the collector, along with the froth stabilizer. fourth stabilizer they have used. When the rotating panel is turned over this large container, what will happen? So when the rotating panel is continuously rotating on the container, it will form a froth. It will form a froth along with the formation of the air. So this froth will be usually lighter in nature so that it will be comes out in the form of skim. It will be skimmed off, or we can say that it will be comes out. When it is comes out, they will dry and they will recover the mineral. The remaining, especially the impurities, whatever it is there in the ore, it will be wetted by the water. This is how, in the form of froth, they are collecting the mineral form of ore. Hence, it is known as fruitation. Remember, in this a large container, they will introduce the rotating paddle and they have taken the mixture of ore, water, collector and a stabilizer. When the rotating panel is continuously rotating, the air will be comes out. At the same time, the froth will be developed. The froth will be developed. And this froth, once it is skimmed off, once it comes out, it will be recovered and it will be drained to obtain the mineral ore. The remaining impurities, it will be in the form of, it will be wetted by the water and it will be collected later. This is how, in the form of froth, they are collecting the mineral ore. Hence, it is known as fruitation or the fruitation process. Next, we will understand what is this collector, what is this a stabilizer, why we are using this. Let us understand now. So, the collector is an example for the fatty acids or the xanthates. It enhances the non-wettability of the mineral particle. So, and the mixture, we have also added the collector to enhances the non-wettability of the mineral particle or with the mineral ore. Then froth stabilizer also we are using, which stabilizes the froth. Once the froth which is formed on the upper surface of this container, it will be skimmed off. To stabilize that also we use a stabilizer. So it will stabilize the froth. But sometimes, it is possible to separate the two sulfide by adjusting the proportion of oil to water by using depressants that prevents the entry of selectively ore into the froth. Already we have learned that this technique will be generally used for the concentration of the sulfide ore. Suppose if any two ores which consists of the two different sulfide, in such cases we can use the depressant. So, it will separate the two sulfide ore which will be formed in the form of froth. For example, you can take the zinc sulfide and the lead sulfide. The depressant will be used is sodium cyanide. Suppose in your ore that consists of both lead sulfate and the zinc sulfate. In such cases, they'll use the depressant. So, it will separate the two ore which is also two sulfide ore which is formed on the froth. It will be formed on the froth and it selectively prevent the zinc sulfate from the coming out of the froth but allow the lead sulfates to come with the froth. This is how, even though if your ore which consists of a two sulfide, that can also be separated by using depressant. Where if you use the depressants, that causes one of the ore to get froth and another ore to retain on the container itself. Like this, if the two sulfide ore is also there, we can easily separate it out. Hope you are understood with this beautiful, important separation technique which has been made in the metallurgy. And in the next class, we are going to understand with the last concentration technique, that is the leaching process, extraction of the crude metal from the concentrated ore. So, hope you all understood with this today's session, and in this session, we have learned that what is metallurgy, what are the important terminology which we used in the metallurgy we have learned, and in addition to this, we also learned about the occurrence of the important metal in the form of ore. And also we learned about the concentration of the ore. Under that we learned about the 3 important technique. So that's all about today's session. We'll meet you in the next session. Till that, take care, be safe. Thank you.